The next set of classes we need to look at are the base SQL classes themselves. They can all be found in this class, in this AEF called 3 Server Base. The first one to look at is the one called Provider TSQL. This class is basically a syntax class. If we open up and have a look at all the code in, you will see that largely it is generating SQL statements. Large swags of them. Now, what happened in the first iterations of my classes was that I generated a provider class for each server type that I wished to support. I had one for Oracle, one for DB2, I started one for MySQL, and of course I had Microsoft SQL Server. Sybase was very close to SQL Server. But as various companies decided not to use anything other than Microsoft SQL Server, I've decided to concentrate on SQL Server. You will notice that some calls use an open schema command. Now, if the OLEDB provider that you're using does not support open schema, then a lot of this class-based code will fail. That was another reason why I stopped using MySQL and Postgres, because they did not support the open schema commands insisted on by ANSI 92. But by and large, this class, the provider class, is where you will come to find SQL syntax specific issues or SQL syntax construction. So a lot of work has gone into here to make sure that what you produce from Microsoft SQL Server generates correct SQL. So that is the SQL class. Now you will find it has things like get database array, get constraints array, get views script, get. So the other side of that is format. So if you're looking for the code to create a table, you will see format create table, and here is where it will take an array of fields and generate the SQL to create a table. So you'll find it in create table script. And if you're using all my debug output statements, you'll be able to see all of these commands executing through DBGView. You'll also find that there'll be SQL data transform methods such as get SQL data type. If we go to that method, there is an array of SQL data types, and this is where it will convert the SQL specific server instance data type to an ADO number type. Remember, we're dealing with ADO, not ADO.NET, but ADO. ADO is based on OLEDB. So there are predefined known data types that have to translate to a data type within the server that we're using. We have modified Roberts base classes to act with SQL Server 2008, which has new data types, not necessarily defined in ADO. We compensate for that in our classes. So the format commands will produce syntax. So you'll see this will build an insert into statement. Something like get will retrieve data out of the SQL Server itself. That's the provider class. The start point is a connection class. Now the connection class basically handles all calls to and from the SQL Server. When it's initted, we'll just have a quick look at the init. In here we pass in some primary parameters. I use my global class to remember what the last connection was. Quite often I will attempt to reopen the current connection based on the conditions of the last connection. But I can do such things as force it. I can attempt to use a connection string and connect directly to a new connection. I can connect based on a database name. I throw out the connection to a log so I can see what my connection was. And then if it passes, I then set global object values if the state is open. Save the various variables to my global object for use next time, and leave the method. Now, a lot of things happen on the connection class. such as when I want to execute a select statement, I have a method called exec select. Almost everything you will see is wrapped with an error handler, so that if it fails, I will handle the errors, or you can, rather than have the user get a crash and some kind of error crash that bombs the application out completely. You can choose how to deal with the error, but mostly I will throw you back to the application with a standard error message. Now the exec select, for example, takes cursor properties. We can use client-side cursors, server-side cursors. We can put the cursor location on the client or the server. We can use asynchronous fetching. So, for example, say the record was trying to retrieve 1,000,000 rows, we could actually return the user back to the application immediately, or wait for the 1,000,000 rows. So all of these things are parameters that you can control within the application, or use application level defaults. So that's an exec statement, but there could be a stored procedure. So I have one which executes a stored procedure, takes in parameters. The parameters can be passed in by array or by reference, and it executes the stored procedure. Likewise, this exec command, which is for update, insert, and other kinds of SQL statements, alter database, alter table, alter structure, and so on. Then I have standard methods such as find all tables, which will simply return an array of all tables in a database, all columns in a table, and so on. I can get and set the recovery modes. I have some simple methods such as get string value, which is expecting a chunk of SQL to look for a certain string and return a string value. So get name from some table where the address contains the suburb of X, and if it returns nil, you'll get an empty string. So I have some standard methods like that. All of these are based on the connection class. So you see that when I want to enable triggers or disable triggers, I will call a method on the connection class. The connection class will use the appropriate provider class syntax and execute the command. You'll see in this class I also have my standard DB server class. The DB server class is nothing more than a pass-through for the standard DB server methods. I have my own RDD, you've seen this before, where all the methods for the DB server class are implemented. And I have implemented these directly to replace those of the standard class. Where's methods that are meaningful? Create index. I do the code myself. I found a lot of bugs and performance issues with the standard VO DB server RDDs. However, you have a look at the SQL Server class, and the SQL Server class looks identical to the DB Server class. It has all the things such as count, copy DBF, copy SDF, current order, delete all, flock, rlock, field put, field get, everything you'd expect to find in a DB Server class. It has additional ones such as drop order trigger, drop triggers, create triggers, enable triggers, foreign keys, primary keys, key values, new stuff that's only relevant for SQL. But because it has all the DB server class, this is what enables your classes to basically run in your applications without much modification. For every DB server construct, there is an SQL equivalent. That's not to say they'll work with the same performance benefits, but it is to say they will work. Now I have some additional classes that are quite useful, such as SQL statement. So if you instantiate the SQL statement class with a chunk of SQL, you'll be able to read accesses and assigns to read off the properties. So this is quite useful. If you've got a piece of SQL and you want to know what database the SQL was working from, you just simply use the database access of this statement class and it will tell you. So now you can easily parse SQL statements in your code to find out whether there was a whereby clause, an order by clause, or whatever else. I have a SQL table class which enables you to find all such things as like an array of columns, an array of defaults, whether it had a primary key, whether it is nullable. So now all you need to do is instantiate this table class with the table name, and it will give you properties for that table class. So this allows you to base some decisions on the structure of the table. I have server classes and temporary table classes which basically mimic a standard DB server. So again, you can create a table based simply on some SQL, and it will generate a class for you that will then behave as if it was a DBF. Now, this allows you to throw them on browsers, on data-aware windows, and other sorts of constructs. There's a range of other classes in here that are very useful. Here's the connection string class. So again, based on the connection string class, you can read off the password and reset the password. So you can use a standard object-oriented approach to managing strings. I have some other classes here that we'll talk about later that go into bulk inserts that my SQL master and table generators use. Lastly, there is a progress bar and a progress bar class that's in here in the SQL Server class so that this does not need to access any other GUI. So you can use a runtime GUI to do things such as present a progress bar without it having to be attached to other GUI classes. That, in a summary, is the SQL Server Base classes. The only other one that's of use to know about is the Objects class. This class carries all the SQL statements that you would use to create your own functions and triggers and stored procedures. So for example, there's a small function here. Because it's defined within this SQL Objects class, my class library will manage it. And therefore the SQL Server will generate this class automatically when the application is first started. I have tools to regenerate these classes, so that to regenerate these functions and stored procedures. I have tools to drop all stored procedures, drop all functions, create all stored procedures, so that under code control you can very easily regenerate your SQL Server database. The idea here was that you never need a DB admin. The application will be able to completely create your database, all the functions and stored procedures you need, all the triggers and views you need, without a human being intervening.